Okay, so we are moving on to to dividing radicals. These are a little bit trickier. They combine a lot of different skills. One of the first things that we look at when we're dividing, so dividing is whenever you have a radical in the denominator, is can it be simplified? So I look at 6 and 25. Now the 5 is on the outside, so we cannot do anything with the 5 on the outside. I look at the 6 and the 25 and realize that they can't be simplified at all. So what I need to do is I need to get rid of that radical in the denominator. One of the first things that I do to get rid of that radical in the denominator is I actually figure out what I have and what I need. So this 25 right here, well, 25 divided by 5 is 5, divided by 5 is 1. So 25 is 5 fives. Okay, so I'm going to just rewrite that so it just kind of tells me what I have, and we'll talk about what I need. So this is 5 cubed root of 6, and this is the cubed root of 5 times 5. Now, in order to get something out of the root, I need that set of numbers. So this right here is a cubed root, so I actually need 3 5s underneath my cubed root to get rid of that cubed root symbol. So I need, since I have 2 5s here already, I actually just need a third 5. So what I'm going to do is I'm going to multiply by my very fancy one. I'm going to multiply the cubed root of 5 in the denominator. I also have to do it in the numerator to make this into a very fancy 1. Otherwise, it'll change my problem. So this is just right here. This is equal to 1. This is just a very fancy one. So once I realize that, okay, I multiply across. So this is going to be 5. It's going to be the cubed root of 6 times 5. And in the denominator, you don't necessarily need this step, but I just want to show you. I end up with, when I multiply across, I end up with the 3 5s that I needed. So I simplify this. This is going to be 5 cubed root of 30 over. Now, 5 times 5 times 5, that's a group of 3 5s, so they come out, and so that's what I'm left with. Okay, I go through my simplification. I know 5 divided by 5 is 1, and so I have this 30 here. I'm just going to check on this 30. 30 divided by 2 is 15. 15 divided by 3 is 5. 5 divided by 5 is 1. There is nothing in here to simplify, and so my answer is just going to be the cubed root of 30. Moving on to 25. Again, the same thing. I like to simplify first. It can make it a little bit easier. So I looked at this right here, and even though I cannot divide by my radicals, I realize that they do have a common factor. 10 and 8 can both be divided by 2. Okay, so 10 divided by 2 is 5, and 18 divided by 2 is 9. What I also notice is they both have m's here. And so I can also subtract 3 minus 1. So remember when you're dividing. So I move across. This is going to be the square root of 5m squared over 9. I go through, I separate this because I can't do anything more with both of them under the root. This is going to be the square root of 5m squared over the square root of 9. I take my square root, so 5m squared, I have a pair of m's here, so I know an m is going to come out, and so this is radical 5, and then I know that the square root of 9 is 3, so it's m radical 5 all over 3. Number 26. Okay, what I notice is I have what's called a binomial at top. This is separated by addition or subtraction. I can't really simplify this the way it is. I do see that I have a 2 right here in the denominator. Okay, so I know I'm going to have to rationalize my denominator. And so I don't have to worry about what's up here. It's just the denominator can't have a radical. So I look at this. I have 1, 2 here. If there were 2 2's there, then I would be able to get rid of the radical symbol. So I multiply by radical 2 over radical 2. Okay, so this right here is one term. There's no addition or subtraction, so I can just multiply by radical 2. I don't have to do distributive property. I just multiply across. I do have to do distributive property with the top, okay, because this right here. Anytime you have a binomial, two terms, you have to do distributive property. So I multiply across. This is going to be the square root of 5 times 2 minus the square root of 2 times 2 over outside. 4 is on the outside, can't do anything with that. And then I have the two 2's on the inside. And you can skip a couple steps, which is fine, but it's just the way I do it. My second step is to simplify. I know 5 times 2 is 10. I know that there are a pair of 2's here, so that's just going to be plain. So 2 comes out. In the denominator, I have my 4, and here I have a pair of 2's, so the 2 comes out. Simplify a little bit further, so this is going to be radical 10 minus 2 all over 8. I have nothing on the outside here, so even though 10, 2, and 8 are all divisible by 2, because the 10 is in the radical, I can't do any more than that, so I kind of end it right here. Now 27 is different. What you notice with 26 is there's no addition or subtraction, but if there's addition or subtraction, you have to do something a little bit more. So for 27, I'm going to show you, if I just multiplied this by radical 2 over radical 2 like I did the other one, what happens is I have to do distributive property. So I have 2 radical 2 in the numerator, but in the denominator, I'm going to have a 5 radical 2 plus a 3 radical 2 times 2. So it'd be 2 radical 2 in the numerator. I'd have a 5 radical 2, and I'd have a 3 times 2. If I keep going, what you'll notice is that I still have this radical there. So that is not efficient. So we don't do it that way, okay, because it does not get rid of your radicals. So we have to find a different way. And so what we do is, what we talked about in our imaginaries unit is multiplying by the conjugate. Okay, this is just a super fancy one. Okay, so this is 5 plus 3, or geez Louise, wrong. Not that this is, okay, 5, but instead of plus 3 radical 2, we're actually going to multiply by 5 minus 3 radical 2. And I'll show you what happens, kind of little magic here, because we want to get rid of our radicals. And so we put this in the top as well, because we want it to be a really fancy one. So we're going to have something crazy in the bottom and crazy in the top. My numerator, I have one thing. I'm distributing it into two things. So this is going to be 10 minus 6 radical 2. That was simple. Now this right here, I have a binomial and a binomial. So this is where I have to do my box. I'm going to show you what happens, what's kind of magical in this box. We have a positive 5, 3 radical 2. And I have a positive 5 minus 3 radical 2. Now a couple things that you notice when you're doing your box method is that if one is plus and one is minus, what you're going to be doing here is the number here is always going to be this number squared. So this is going to be 25. What you also notice is even though one is positive and one is negative, these are still going to be a 3 times 3. So 3 times negative 3 is negative 9, and radical 2 times radical 2 is radical 4. So basically, you're going to be squaring these terms as well, and that's what's going to end up here. And what you'll see if you can think ahead a little bit is this ends up being a whole number. We have no radicals here. The other thing, but the reason why you do your plus and minus, 5 times 3 is positive 15 radical 2. And then 5 times negative 3 is negative 15 radical 2. And what you notice is these two right here, they add to be 0. They cancel each other out. They add to be 0. And so what you're left with is you're not left with any radicals in the denominator, just kind of the magic of when you multiply by what's called the conjugate. So this is 25 minus 15 radical 2 plus 15 radical 2 minus 9 radical 4. So I apologize, it kind of goes off the page. I simplify. 10 minus 6 radical 2, can't do much there. I have my 25 still. I have my 15 radical 2, negative 15 and positive 15, they add to be 0. What I notice is the radical 4 is 2. Okay, so I have 10 minus 6 radical 2. This is going to be 25 minus 18. 10 minus 6 radical 2. 25 minus 18 is 7. And that's your final answer. There are no common factors for any of the numbers on the outside. The 2 is simplified, so there you go. Okay. 28. So this is the last of the division problems. We have to do something similar here. Actually, it's the exact same thing. We are going to multiply by the conjugate because we know that just multiplying by radical 7 doesn't get rid of this binomial. That's when there's addition or subtraction in the bottom. So these are the super complicated ones. Just take your time. So this says 5 minus radical 7. So I know if I multiply this in the box by 5 plus radical 7, I end up with no more radicals in my denominator. Now for this, I do have to have 2 boxes if you do the box method. Distributive property is a little bit different. So for the top, this is for my numerator. I have 2 plus radical 7 and 5. Sorry, I have 2 here, that looks like a 2 there. It's actually 5 plus radical 7. There we go. 2 times 5 is 10. This is 2 times 1 is 2. Radical 7, remember there's a 1 out here too. 5 times 1 is 5, radical 7, and then I have 1 times 1 is 1. Radical 7 times radical 7 is radical 49. So I'm going to just write all of this up here. So this is 10 plus 2 radical 7 plus 5 radical 7 plus radical 49. That's what's going to go in my numerator. Now I do a box for my denominator. Some of you guys have figured out some shortcuts with this, which is great. 5 minus 1 radical 7, 5 plus 1 radical 7. 5 times 5 is 25. 5 times 1 is 5, radical 7. Negative 1 times 5 is negative 5, radical 7. Negative 1 times positive 1 is negative 1. Radical 7 times radical 7 is radical 49. So I'll write it all out. So this is 25 minus 5 radical 7 plus 5 radical 7 minus radical 49. And I go through and simplify both my numerator and my denominator. So this is going to be 10. I notice that these both have radical 7s. So 5 plus 2 is 7. So I have 7 radical 7. And I know that the square root of 49 is 7 over 25. I have my minus 5 radical 7 plus 5 radical 7. That ends up being 0. And I know radical 49 is 7. I simplify further. 10 plus 7 is 17 plus 7 radical 7. Ooh, it's a lot of 7s. And then 25 minus 7 is 18. I look at the numbers on the outside just to see if they have a common factor. They do not, so that's my final answer, and that is division.